Welcome to the thermalarc181i introductory DVD. This short video will provide you with an overview of what this unit is capable of and how to set one up. This unit can weld using MIG, metal inert gas, stick, shielded metal arc welding, or TIG, tungsten inert gas. Each method has benefits and performance qualities for the type of base material you are welding. To determine which welding process that will deliver the best results for you, first you must decide what material types you will be welding. Will you be welding mild steel, aluminum, stainless steel, cast iron, copper, bronze, or brass, high alloy steels? For example, generally mild steel, stainless steel, or aluminum are good candidates for MIG or TIG welding, while aluminum is a good candidate for MIG. Cast iron, high alloy steels, bronze, or brass are well suited for stick welding. These can still be used with MIG or TIG welding if needed. Here is an overview of the three different welding choices you can make with these units. With all three of these methods, the filler metal, the base material you are welding, weld joint design, and your welding technique controls the quality of your weld. MIG and TIG use a shielding gas to protect the weldment area as well as the tungsten electrode from atmospheric contamination. You can optionally set up the MIG weld without using a shielding gas. MIG welding. MIG uses a constant voltage to maintain the welding arc. MIG welding uses a continuous and consumable wire electrode with or without shielding gas. Both the consumable wire and shielding gas are fed through the MIG gun to produce the weld. The wire electrode comes in various spool sizes and wire diameters, which makes the MIG process preferred for its versatility and welding speed. Stick welding. Stick uses constant current to maintain the welding arc. It uses a consumable electrode to produce the weld. Consumable electrodes contain different materials that are coated with flux for shielding. TIG welding. TIG uses constant current to maintain the welding arc. TIG welding uses a shielding gas fed through a TIG torch and a non-consumable tungsten electrode to conduct the arc to the weld area. This welding process requires a steady hand and a consistent distance between the electrode and the base material, or stick-out distance. Now let's discuss what you need for each welding method. The common materials, MIG gun, electrode holder, and work lead are supplied with this unit. The TIG torch is an optional accessory that can be purchased from your local thermalarc distributor. Your base material, the material thickness, and the filler metal will help you choose the best welding method. MIG welding. You will need to decide what wire and shielding gas combination will be needed. Match the wire material type with the base material you are welding. Wire diameter is another choice you will make based on the weld joint design and material thickness for your weld. We have provided these guidelines for you in your setup chart. See the operation manual for specific wire sizes and recommendations. Generally, these units can run on wire diameters from 0.023 to 0.035. Wire spools typically come in sizes of 8-inch or 4-inch spool diameters. You can weld on base materials from 0.023 to 1/4 inch thick. Note that thicker materials can be welded together using multiple passes. The base material and filler metal determines your shielding gas choice. These recommendations are also provided for you in your setup chart. See the operation manual for details. The shielding gas protects the molten weld puddle from the surrounding atmosphere. Stick welding. The size and type of consumable electrode, or sticks, used with this operation vary and depend on the base material. See the operation manual for specific rod sizes and techniques. TIG welding. TIG welding uses a non-consumable electrode, or tungsten, and argon gas to weld. In TIG, the electrode is primarily tungsten alloys. You will have to choose which electrode diameter is best suited for your use. See our setup chart for details. On these units, electrode diameters range from 0.040 to 1/8 inch. A filler rod can be used to add material and strength to the weld. Read and follow the directions provided in the operation manual. Do not plug in the unit until told to do so. The following is an overview of how to properly connect the welding accessories for each welding process. MIG setup. MIG welding can be set up for welding with or without shielding gas. To begin, we will discuss the MIG welding setup with shielding gas. Apply power to unit and turn the on-off switch to the on position. Select MIG with the process switch on the front panel. When installing MIG gun, make sure a locking nut is backed out to prevent binding. Insert gun trigger connection if applicable. Twist lock your polarity lead to the positive connection. It is essential that the male plug is inserted and turned securely to achieve a good connection. Now twist lock your work lead to the negative connection and attach the work clamp to the material you are going to be welding. Make sure that the work clamp is connected securely on a clean workpiece. Make sure to verify that you have the correct drive roll type, smooth V-groove, and size selected for the wire diameter you will be using. To do this, look at the stamped number on the side of the drive roll. The number that is facing out is the groove that will be in use. Also make sure that your gun consumables are correct for proper operation. Install the wire spool onto the plastic spool hub for 8-inch spools, making sure that when the wire is installed, the wire feeds from the bottom. Also make sure that the hole in the plastic reel is aligned with the plastic pin on the spool hub for braking. If using a 4-inch spool, remove the plastic hub and install the wire reel onto the shaft. Place spring, plastic spacer, friction washer, brass flat washer, 4-inch diameter spool, flat washer, nut with nylon insert. Once reel is on shaft, reuse flat washer and spring assembly to tighten against spool for braking. Tighten nut in center of spool hub for proper brake tension, making sure tension is not too tight, which can cause drive motor to struggle while pulling wire and cause slippage. To install 8-inch spool, install brass flat washer, wire spool hub, friction washer, plastic spacer, spring, flat washer, nut with nylon insert. Adjust tension according to manual. Eight-inch spool, spool hub nut. If tension is too loose, wire can unravel from spool, causing tangling. Adjust tension so spool can move freely without unraveling. Next, remove the wire from the spool, making sure not to let go of it to prevent unraveling. Cut the bent end of wire and pull the wire up to the inlet guide and feed into wire drive system. Advance wire into gun and pivot pressure arm down on top of the wire and apply tension arm. When applying tension, make sure not to apply too much tension to the wire, which could cause pinching. Proceed to pull the gun trigger on the MIG gun to feed wire through the gun. Continue to hold the trigger until the wire protrudes through the tip. You have now fed wire through the MIG gun successfully. Be sure to follow all safety instructions that are included in the operating manual when installing the gas flow meter to the shielding gas cylinder. Install the flow meter to the appropriate shielding gas cylinder. Thread large nut onto cylinder, making sure not to over-tighten. Connect the gas hose between flow meter and power supply and tighten. When installed, open valve on cylinder and check for leaks. If no leaks are present, remove tension arm from wire and pull gun trigger to allow gas to flow through MIG gun. Set flow rate to approximately 20 to 30 cubic feet an hour for workshop welding or 30 to 40 cubic feet an hour for outdoor welding. Now set your voltage and wire speed according to the setup chart on your unit. This chart will help aid in determining how to set your voltage and wire speed according to the material you are welding. You are now ready to MIG weld. MIG welding with gasless or flux core wire. When installing MIG gun, make sure a locking nut is backed out to prevent binding. Insert gun trigger connection if applicable. Twist lock the polarity lead to the negative output connection. Now twist lock your work lead to the positive connection and attach the work clamp to the material you are going to be welding. See previous method for drive roll and wire feed setup. You are now ready to MIG weld with gasless flux cord wire. Stick setup. Select stick with the process switch on the front panel. Twist lock your electrode holder to the positive output connection. Twist lock your work lead to the negative output connection. Connect your work clamp to the material that is going to be welded. Make sure that the work clamp is connected securely on a clean workpiece. Adjust current setting that is applicable to the material you are going to be welding. Place electrode in electrode holder. You are now ready to stick weld. TIG setup. Select TIG mode with the process switch on the front panel. Twist lock your TIG torch to the negative output connection. Twist lock your work lead to the positive output connection. Make sure you remember to securely connect the work clamp to a clean surface on the material that is going to be welded. When installing TIG torch consumables, please refer to your operating manual for proper installation. Connect the gas flow meter to the cylinder and tighten brass nut, making sure not to over-tighten. Please refer to the operating manual for proper instructions when installing flow meter for the first time. Open shielding gas cylinder valve and check for leaks. If no leaks are present, open the TIG torch valve and set flow on the flow meter to approximately 15 to 20 cubic feet an hour. Adjust your current based upon what material you'll be welding. Different base materials and some options determine the best control settings. When preparing to weld, review the control settings for your base material and options. You are now ready to TIG weld. MIG welding with gas on mild steel. By using the setup chart, if you were welding on 18 gauge mild steel and using a welding wire type of ER70S6, 30 thousandths diameter, your wire speed would be set to 300 inches per minute. Voltage would be set to 17 volts, and inductance would be set at 8. Your shielding gas type would fall within a range of gas mix percentages. MIG welding without gas. For most gasless flux core wires, the MIG torch polarity lead and the work lead are reversed for MIG welding without gas. Switch these leads before setting the controls. See the setup chart. For example, using wire type E71T11 with a diameter of 30 thousandths and a base material thickness of 18 gauge, your wire feed speed would be set at 160 inches per minute, voltage would be set at 15 volts, and inductance set to 10. You would not use a shielding gas. Stick welding. The choices for stick types vary widely depending on the base material. By using the setup chart, if you were welding on 1/8 inch base material and using a 1/8 inch 6013 electrode, the amperage would be set at 100 to 135 amps depending on the welding joint. The arc control setting would be 4. TIG welding. Using the setup chart, if you were welding on 16 gauge stainless steel material, you would use a 16th tungsten electrode and a 16th stainless steel filler rod. Your amperage would be set to 40 to 70 amps. Because your rod is a non-consumable rod, there would be no feed setting. Your shielding gas would be pure argon. Safety is our main concern and your protection is important. Please always observe and use the recommended safety practices with this equipment. With your unit set up and controls properly set for welding, you are ready to begin.